All right, so now that we know what a subset is, and we know how to find all the subsets of a given set, we can talk about power sets. So definition, if A is a set, then the power set of A, which is denoted like this, is the set of all the subsets of A. So the power set is itself a set, and its elements are the subsets of A. That is, the power set of A is the set of all S, such that S is a subset of A. For example, what is the power set of the set A, 1, 5? So first of all, one element of the subset is the empty set, because the empty set is a subset of every set. Then we can also take a single element of the original set at a time. So we can have any of these three. Well, we have all of these three. These are more elements of the power set. And then we can have elements which are sets of size 2. And then we finally have this set. So this entire thing, this entire thing is a set. Okay, it's a set whose elements are sets, and those elements are all the possible subsets of the set of this original set that was given inside the parentheses. There we go. Right. So so this is the power set. This set is the power set of this particular this is the power set of the set A, 1, 5. Another example, what is the power set of the set whose single element is 1? So first we have to solve the inside. Before we can do the outside, we have to solve the inside. So for the inside, we want to know what is the power set of the set whose only element is 1. Well, that's going to be this. We're going to have the empty set, because the empty set is a subset of everything, of every other set, and the set whose only element is 1, that's a subset of this set. Okay, so now we need to do the outer operation, power set of this. Okay, so we have a set of 2 elements, and we're trying to find the power set of that, and it is this. So we have the empty set, then we have the set containing the single element, the empty set, then we have the set containing the single element, the set 1, and then we have the set of 2 elements, which are the empty set and the set just containing 1. Another example, what is the Cartesian product of the power set of the empty set and the power set of the set whose only element is the empty set? So again, this on the left is the power set of the empty set. We want to find the Cartesian product of that with the power set of the set whose only element is the empty set. Okay, so we're going to do each of these power sets individually and then find the Cartesian product of those 2 new sets. So first, what is the power set of the empty set? Well, the empty set has only one possible subset, the empty set. So the power set of the empty set is a new set, right? So the power set is always a set, and the elements of the power set are all the possible subsets of the original set. So the original set is the empty set. So the power set of the empty set is the set of all possible subsets of the empty set. And there's only one possible subset. It's the empty set itself. So we have a set whose only element is the empty set. That is the power set of the empty set. Now we need to find the power set of this, right? The power set of this. So we do that. Now we need to find the Cartesian product. So here, this set has 1 element. This set has two elements. So we can write out formally using the definition of Cartesian product. We want all ordered pairs x, y, such that x is an element of the set whose only element is is the empty set, and y is an element of this set. Okay, so x has to be one of the elements of this set. It happens to be that there is only one element here, and y has to be one of these two elements. So y could either be this or it could be this. Okay, so here are the two possible ordered pairs that we can create. So this set of the two ordered pairs is our answer. The set of these two ordered pairs is our answer. Include whatever it should include, yeah, including the. So the Cartesian product is a set. So that's why we have these curly braces at the beginning and end, because the Cartesian product is a set. It's a set of ordered pairs, or it's a set of lists. Now here we have two facts. If A is a finite set, then the cardinality of the power set of A is defined as is equal to 2 to the power of the cardinality of A. Okay, so this just follows directly from a fact that we had earlier, which is that if I have a subset of n elements, if I have a set of n elements, it has 2 to the power of n possible subsets. All right, so this just follows directly from that. And here's another fact that we had mentioned earlier. If A and B are finite sets, then the cardinality of the Cartesian product of A and B, right, the cardinality of A cross B, is equal to the cardinality of A times the cardinality of B. Now let's do two examples using these facts. So the first one is, what is the cardinality of the power set of the set whose only element is 1? Now we saw this just before, and we figured out what all the elements are, but now let's try to do it without figuring out what the elements are. Let's try to just use these facts to figure out this cardinality. So using this fact, this is the power set of something. So this would be, the cardinality would be 2 to the power of whatever the size of this is. Oops. So again, this is 2 to the power of the cardinality of the power set of the set whose only element is 1. Now, what is the cardinality? What is the cardinality of this? Well, so this would be, again, 2 to the power of the cardinality of this little set here, right? So far we have 2 to the power of 2 to the power of the cardinality of the set whose only element is 1. Now this cardinality is just 1. So this is 2 to the power of 2 to the power of 1, which is 4. Another example. What is the cardinality of the power set of the empty set cross the power set of the set whose only element is the empty set? Now we just like before, we saw this example before, but now let's try, instead of trying to find the elements, let's try to follow the facts, follow the rules, and see if we can figure out the cardinality. And actually before that, let's go back to this example that we were just doing. Let's go back to see it. We got the answer of 4. Let's see if that matches up with what we found earlier. So here we found, this was our answer before, and this has one. Let's count the elements. This is one element. This is the second element. This is the third element, and this is the fourth element. So indeed, there are 4 elements in the answer. Okay, so that's good. Now let's do this example. So again, we're following the rules. So if A and B are finite sets, then the cardinality of A cross B is going to be the cardinality of A times the cardinality of B. So in this case, it would be, we want the cardinality of the power set of the empty set times the cardinality of the power set of the set whose only element is the empty set. So this is 2 to the power of the cardinality of the empty set times 2 to the power of the cardinality of this set. Now, the cardinality of the empty set is 0, so that would be 2 to the power of 0. The cardinality of this set, the cardinality of this set is 1, so that would be 2 to the power of 1. So we have 2 to the power of 0 times 2 to the power of 1, which is 1 times 2, which is 2. Let's check to see if this matches up with what we found earlier. And the answer is yes. Here's one element, and here is the second element. So indeed, our Cartesian product has in fact 2 elements, and we see if we follow the rules, we get the same cardinality. So that's very nice.